Hello from Barangaroo. This new reserve has got sandstone blocks everywhere, being used as decorative stone. It's really quite impressive. Our whole city, the Sandstone City, is shaped on the geology that it was built on. Let's find out more this week. This week, we're going to consider the Hawkesbury Sandstone. What is the Hawkesbury Sandstone? If you live in Sydney, then this is the rock you are most likely to see every day. Maybe you'll see it in a road or a rail cutting. Maybe you'll see it as a building stone or a decorative stone, maybe as a wall in someone's garden. And most of this sandstone will be the Hawkesbury Sandstone. The Hawkesbury Sandstone is widespread within the Sydney Basin of New South Wales. The deposits are approximately 225 kilometres long in the longest direction, which is towards the northeast, and around 75 to 100 kilometres wide. The Hawkesbury Sandstone was deposited in the Triassic period of geological time. The Triassic is between 200 and 250 million years ago, and the Hawkesbury Sandstone was deposited around 220 million years ago. The Hawkesbury Sandstone records the environmental history in its sediments, in the same way that the more recent Botany sands also record a recent environmental history in their sediments. For the Triassic Age Hawkesbury Sandstone, it's the scale of the sedimentary features, and especially the scale of the cross-bedding, that suggests the river was a large braided river, probably the size of the Brahmaputra today. And that is shown in the figure on the right-hand side, where on the top of this figure you can see some features of the modern Brahmaputra River, and you can see the scale of some of these features. So there's a first order channel width of 10 to 20 kilometres wide by 50 metres deep, with islands up to 8 kilometres wide, and then channels within this second order channels. And if you compare that to the features you can see preserved in the rock record, so here we have the Hawkesbury Sandstone on the coast at Kurnell. You can see some of these sand bodies. These are the fifth order sand bodies. These are tens of meters thick, and they're a similar sort of scale to those that you'd find in the Brahmaputra. So that's the evidence that's provided. The Botany Basin is situated on the Hawkesbury Sandstone, meaning that where Botany sands are present, like on campus, there will be Hawkesbury Sandstone underneath. So one of the important features of the Hawkesbury Sandstone is that it contains this record of Earth history, like many geological sediments. And one example here is that the sedimentary structures can be analysed to understand the depositional environment for when the sandstone was deposited. The cartoon at the top shows cross-bedding, which is a structure that can inform how sediment was transported in a river, and by implication, the direction of the water flow and how fast the water was moving. So in the cartoon in the top, the arrows show the water direction going from left to right. And you can see the sediment particles at the base of the river being transported along the side of a dune and then tumbling down the other side. So this dune is forming from left to right, and it's going to increase in height and dimension as you go from left to right. And over time, this gets preserved in the rock record, and this is what we see in the lower half of the cartoon, a whole series of these dunes where you can then interpret the water flow from having gone from left to right. And in the picture, which is taken from the centre of Sydney, you can see the cross-bedding features again here. And so by seeing these features, we can infer that the water flow, when this sediment was deposited, was flowing from left to right. So I described what's written in the text here. To form cross-bedding, sand is transported as sand dune-like bodies or a sand wave. Sediment is moved up and eroded along a gentle up-current slope, and then redeposited or avalanched on the down-current slope. And if this process continues and there's more sediment deposited than eroded, you'll have a build-up of cross-bedded sandstone layers. And the inclination of the cross beds indicates the transport direction and the current flow, and the style and the size of the cross bedding can be used to estimate current velocity. And orientation of the cross beds allows us to determine the water flow direction. A second reason why it is very important to understand the Hawkesbury Sandstone is that Sydney is surrounded by national parks, and these are significant tourist attractions and of great value to those of us that live here in the city. And the predominant geology of these national parks is the Hawkesbury Sandstone. And the Hawkesbury Sandstone is a major influence on the bio and geodiversity of the national parks. I've downloaded for you the Sydney Basin 1 to 500,000 scale geological map from Geoscience New South Wales on the lower right hand side of this slide. And this shows the extent of the Hawkesbury Sandstone. So on this geological map, the Sydney Basin is delimited by the blue and the green coloured sediments. Blue is heading towards the Permian and the coal measures. So this is Newcastle to the north and Wollongong and the Illawarra to the south. Sydney is situated in the centre of the basin, and the Hawkesbury Sandstone is this darker shade of green that covers this area here, and is surrounded by other sandstones around the edge. Where I'm recording this from on the New South Wales Central Coast is the Terrigal Sandstone. And although mostly sandstone has been deposited, there are also some interbedded mudstones and shales which reflect a change in the environment away from a large river. And where you find these mudstones and shales, you will find that they don't transmit water through them so well. They are more of an aquitard, less of an aquifer, which means there's more moisture available in the rock. And you often find different vegetation, and often endangered communities. And a third reason to understand the importance of the Hawkesbury Sandstone is that it has an economic value, both as a building stone and as a decorative stone. When Europeans arrived in what's now known as Sydney, they used the local geology as a building stone. And today you can see many of the historical buildings from that era constructed of Hawkesbury Sandstone, especially in the rocks, the location where the first settlers made a base. And one of the distinctive features of the Hawkesbury Sandstone is the distinctive coloured banding that you often see in this. If you haven't noticed this before, have a look out. Buildings and stones is often used as an ornamental or decorative feature. And this is called ferruginous banding. So ferruginous meaning iron, so it's made from iron banding, and it's found throughout Sydney, used as a decorative stone. And one of the very good examples of finding this is if you go for a walk to the new Barangaroo Reserve, where I shot the introductory video, you'll find there's many great examples of this coloured banding, this ferruginous banding in the sandstone. So it's a beautiful decorative stone, and it's a practical building stone. What's happening in class this week? This week we have a field class, and we're going to go to the rocks in Sydney Harbour, and there you'll see a quarry that was used by the first European settlers. You can inspect the fluvial architecture of the Hawkesbury Sandstone, and you can investigate some of this ferruginous banding. So the aim of the field class is to introduce you to the Sydney Sandstone, both as a big river sedimentary deposit, as well as the properties that has led to it being used as a building stone. And your learning outcomes include your observations of aspects of the sedimentary geology of the Hawkesbury Sandstone and how that relates to its interpretation as being deposited by a big river. And you'll also learn about the physical and chemical weathering of the sandstone, which is why the sandstone is an excellent building stone, as well as a decorative stone. What do you need to do before the field class? This week I'd like you to read this technical scientific journal paper by Mile and Jones, published in 2003, so it's quite an old paper. And it's called The Fluvial Architecture of the Hawkesbury Sandstone Triassic near Sydney, Australia. And it's published in the Journal of Sedimentary Research. So this is a technical article written for sedimentologists and the experts in the field internationally who know everything there is to know about sedimentary geology. And that's not you. This is a paper that is not aimed at a first-year undergraduate class. So I don't expect you to understand all or even most of the paper, but there are certain reading strategies that you can use to enhance your understanding and learning of the fluvial architecture of the Hawkesbury Sandstone that will help you interpret what you're going to see in the field class. So that's the paper that I'd like you to read. And I want your reading to be very focused on the learning outcomes, which are on the next slide. And I also highly recommend, if you've not read them before, going to either these UNSW pages on reading strategies for difficult material, or going online and searching for other resources for difficult reading. What do you need to understand from reading this paper? So before the field class, I would like you to understand the evidence that was used in the paper that allowed the authors to make the case that the Hawkesbury Sandstone was formed by a large river the size of the Brahmaputra today. And the evidence that they use is largely summarized in two tables. So it's the two tables that I'd like you to focus on. Table 1 in the paper lists the different types of lithofasces that are identified. So I'd like you to be aware of the 3 types of lithofasces that are present in the Hawkesbury Sandstone and how they're interpreted. And table 2 in the paper talks about the different scale of the architectural elements that have been identified in the Hawkesbury Sandstone and how they can be interpreted, again, as a big river. And there's some text starting on the journal page 539, where the authors then compare the evidence from the lithofasces and the evidence from the architectural elements that allow them to make a comparison with the modern day river. So it's this evidence that I'd like you to be familiar with so that when you go into the field and you see actual sections of the Hawkesbury Sandstone, you would have a better chance of being able to identify the different lithofasces and the different architectural elements. And I think you will enjoy the field trip much more by having that background.